Hello children, welcome to the digital class. In this session, you are going to learn what are rational numbers and how to represent them on the number line. Before going to our session, let us recall what are natural numbers, what are whole numbers and what are integers. Objectives of this session: you can understand what are rational numbers, you can represent rational numbers on the number line, you can identify the rational numbers on the number line. Now students, you try to observe the line. I made the line into parts separated with equal distance. Now whenever we start counting, we start with the number 1. So first number 1, next 2, next 3, next 4, next 5, next 6, next 7, next 8, next 9. Here we started counting from 1 and the next number is 2 and the next number is 3. Here the difference between any two consecutive numbers is 1. We call these numbers as counting numbers or natural numbers. Natural number set is denoted by n, and you can see the representation of natural numbers on the screen, that is n equal to 1, 2, 3, 4, 5, 6, 7 and so on. Now before going to the whole numbers, suppose I consider a bag with 5 books in it, and if I ask a question, what is the number of books in the bag? You say there are 5 books in the bag. Suppose if there are no books in the bag and if I ask a question, what is the number of books in the bag? You will say there is nothing or without anything. This nothing or without anything can be considered as 0. Students, observe the number line again. I made this line into parts separated with the equal distance and I started counting from 0. Next 1, next 2, next 3, next 4, next 5, next 6, next 7, next 8, next 9. Here the number started from 0. So we call these numbers as whole numbers, and whole number set is denoted by W, and you can see the representation of whole numbers on the screen, that is W equal to 0, 1, 2, 3, 4 and so on. Next children, now we observe the number line and try to answer the questions along with me. What are the whole numbers between 0 and 4? Now you observe carefully the number line. You can see the numbers between 0 and 4. Yes, you are correct. 1, 2 and 3. Now can you guess the whole numbers between 4 and 9? Yes, let us see that. 5, 6, 7, 8. So we have 4 whole numbers between 4 and 9. Yes, you are correct. 5, 6, 7 and 8. Now children, you observe the picture carefully. There is a frog on the ground level and you can observe a staircase which is above the ground and also below the ground, and which can be seen by using upward and downward directions with the help of arrow marks. Now we observe this. Here the frog jumps 1 unit above the ground. As it is jumping 1 unit above the ground, I am taking it as plus 1. Now you see, it jumps for 2 units above the ground, next 3 units above the ground, next 4 units above the ground, next 5 units above the ground, next 6 units above the ground. Here you can take the numbers as plus 2, plus 3, plus 4, plus 5 and plus 6. Now I will ask you a question. If this frog jumps downwards by 1 unit, what we have to take? Let us see that. Here the frog jumps 1 unit. I am taking it as minus 1 because it is the direction opposite to the previous one. Next minus 2, next minus 3, next minus 4. Here in the picture you can clearly observe on the ground, above the ground and below the ground. I have taken ground level as 0, above the ground as positive numbers, below the ground as negative numbers. Now you can observe the number line on the screen. To the right side of 0, we have to take positive numbers, and to the left side of 0 we have to take negative numbers. Students, here you have to remember this thing clearly. Numbers to the right side of 0 are always positive and numbers to the left side of 0 are always negative, which you can see on the screen. Now, let us take some examples of negative numbers which we use in our day to day life. In business, profit denotes positive value and loss denotes negative value, and in the same way in measurement, height denotes positive value and depth denotes negative value. Now, temperature more than 0 denotes positive value and temperature less than 0 denotes negative value. So, these are the examples which we are using for integers in our day to day life. Now, let us define integers. The collection of positive numbers, 0 and negative numbers is called integers. Children, observe the picture on the screen carefully. You can see a cylindrical like structure. In that you have 3 ovals. In the first one, I am taking from minus infinity to minus 1, that is minus 3, minus 2, minus 1, and in the second one I am taking 0, and in the third one I am taking 1, 2, 3, 4 and so on up to infinity. So, here this cylinder can be considered as a integer because it is a collection of positive numbers, negative numbers and also 0. The set of integers is denoted by z, and you can see the representation of integers on the screen, that is z equal to from minus infinity, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 and so on. The highest and smallest integers cannot be defined. So, here students may get a doubt, can we find highest integer and can we find smallest integer? Definitely not. Why? If I take any highest integer, if I add 1 to it, I will get the next integer. In the same way, if I take any small integer, if I subtract 1, I will get the previous integer. So, from this clearly we can understand that the highest and smallest integers cannot be defined. Now, children, you observe the number line. Can you write the integers between 0 and 5? Yes. You have 4 integers, that is 1, 2, 3 and 4. Now, can you write the integers between 0 and 1? No, there are no integers between 0 and 1. Here there are no integers between 0 and 1, but can we expect some other numbers between 0 and 1? Let us see this. Here you have 4 equal objects, let us think as chocolates. If these 4 chocolates are divided among 4 people, let us take 4 by 4 is equal to 1. So, here we can say that each person will get 1 chocolate. Next, if the same 4 chocolates are divided between 2 people, that is 4 by 2, which is equal to 2. So, we say that each person will get 2 chocolates. Next, if the same 4 chocolates are divided among 8 people, we get 4 by 8. What is this 4 by 8? After simplification, 4 1s are 4, 4 2s are 8. So, we will get 1 by 2. 1 by 2 is nothing but half. Half is more than 0, but less than 1. So, we have some other numbers between 0 and 1. Let us see what are those numbers. Now, children, observe this number line. I have drawn another line. I have drawn 3 vertical lines. These 3 vertical lines represent minus 1, 0 and 1. Now, what I did? I have taken the center as 0 and to the right of 0 I divided it into 5 equal parts, and to the left of 0 I divided it into 5 equal parts. Center is taken as 0, and as we are dividing the total into 5 equal parts, if I consider the first part, it is out of 5. So, we have to take 1 by 5. To the right we have to take plus, next 2 by 5, next 3 by 5, next 4 by 5, next 5 by 5. 5 by 5 is also known as plus 1. Now, children, observe this. Between 0 and 1, we have 4 numbers, that is 1 by 5, 2 by 5, 3 by 5, 4 by 5. In the same way, to the left, if I take the first part, I should take it as minus 1 by 5, next minus 2 by 5, next minus 3 by 5, next minus 4 by 5, next minus 5 by 5, and minus 5 by 5 can be called as minus 1. So, here also you can observe that between 0 and minus 1 you have 4 numbers, that is minus 1 by 5, minus 2 by 5, minus 3 by 5, minus 4 by 5. These numbers are called rational numbers, which are in the form of p by q. Here p and q are integers. Here we can observe the denominator is not 0. So, the numbers which are in the form of p by q, where p and q are integers and q not equal to 0 are called rational numbers. Now, let us define that once again. numbers which are in the form of p by q, where p and q are integers and q not equal to 0 are called rational numbers. Now, let us consider some more examples. Here you can observe on the screen minus 4 by 5, 3 by 4, 1, minus 1 by 9, 6, minus 3 by 4, 7 by 8, minus 3 and 0. Here some students may get a doubt. We have the third one as 1. So, how can 1 be a rational number? See, 1 can be written as 1 by 1. So, it is in the form of p by q. So, 1 can be taken as a rational number. Next comes for the 6. In the same way, you can write 6 by 1. So, when we have integers, the denominator can be taken as 1 and we can represent them as rational numbers. Rational number set is denoted by q. In p by q form, p can be 0, but q cannot be 0. Students, try to understand this clearly. Whenever we write a ratio, that is p by q, in that p can be 0, means we can take 0 by any number, but we should not take any number by 0. So, denominator should not be equal to 0. Now, next 0 divided by 0 and any number divided by 0 cannot be defined. So, try to remember this. Once again I am repeating, 0 divided by 0 and any number divided by 0 cannot be defined. On the screen you can observe 0 by 0 and n by 0. Here n can be any integer or not defined. In decimal form of numbers, terminating decimals and non-terminating decimals but recurring decimals are called rational numbers. Here let us understand with some examples. I have taken 0.4. So, this is the decimal form. After 4 it is terminated. Next 2.36, here also it is terminated after 6. Next 5.6785, after 5 it is terminated. Next 256.8975645, after 5 it is terminated. See, these 4 examples are terminated decimals which can be considered as rational numbers. Now, let us consider another 4 examples. 1.3333 and so on. Here you can observe that 3 is repeated. So, it is not terminated, but what you are observing here? Here you are observing that 3 is repeated, means it is recurring. So, we can consider it as a rational number. Next 0.23, 23, 23, 23 and so on. Here also it is not terminated, but it is recurring. Which numbers are repeating here? 23, 23, 23 and so on. So, it is non-terminating but recurring. Next 123.6666 and so on. Here also it is not terminated, but what you are observing here? 6 is repeated. So, we can consider it as non-terminating but recurring. Next 5.235, 235, 235 and so on. Here also you can observe that it is not terminating but it is recurring, means it is repeated. Which numbers are repeated? 2, 3, 5 are repeated. So, these examples are rational numbers which are either terminating or non-terminating but recurring. Now, let us represent rational numbers on the number line. First, here I am representing a rational number which is more than 0 and less than 1. Now, let us consider one example. I have taken here 3 by 4. So, let us consider 3 by 4 with the diagram. Here on the screen you can observe there is a circle which I made into 4 equal parts, and 3 parts are colored with red and 1 part is colored with blue. And what is the fraction of blue? Can you tell me, children? Yes, it is 1 by 4. Why it is 1 by 4? Because out of 4 parts, 1 part is colored with blue. So, we are taking it as 1 by 4. Now, what is fraction of red? Yes, it is 3 by 4. Here you can clearly observe from the screen that either 1 by 4 or 3 by 4 both are rational numbers which are less than 1. So, rational number 3 by 4 is greater than 0 and 3 by 4 is less than 1. Now, let us represent this 3 by 4 on the number line. As the denominator is 4, we have to make 4 equal parts between the numbers. Now, observe the number line. I have drawn 3 vertical lines separated with equal distance. To the left I have taken 0, next 1, next 2. Now I am making 4 equal parts between 0 and 1. Next I am making 4 equal parts between 1 and 2. Now 0 can be considered as 0 by 4. 0 by any number is always 0. Now if I consider the first part to the right side of 0, it is out of 4. So I have to take it as 1 by 4. Next 2 by 4. Next 3 by 4. Next 4 by 4. Right. 4 by 4 can be taken as 1. Next 5 by 4. Next 6 by 4. Next 7 by 4. Next 8 by 4. Children, can you observe our required rational number on the number line? Yes, here it is. Now let us represent a rational number which is more than 1 on number line. Let us consider the example 5 by 3. Here numerator is greater than denominator. So definitely the value will be greater than 1. Now to explain this, I have taken 2 rectangles. These 2 rectangles are divided into 3 equal parts each. In the first rectangle, I have colored 3 parts with yellow, and in the second rectangle, I colored 2 parts with yellow and 1 part with violet. Now, fraction of yellow is, if I consider the first rectangle, it is 3 out of 3, means 3 by 3, plus if I consider the second rectangle, it is 2 out of 3. So I have to take 2 by 3, right. Now what I have to do? I have to add 3 by 3 plus 2 by 3. As denominators are same, we can add the numerators. That is equal to 3 plus 2 by 3. What is 3 plus 2? 5 by 3. Now what is the fraction of violet? It is 1 out of 3. So we have to take it as 1 by 3. And on the screen you can observe rational number 5 by 3 greater than 1 and 5 by 3 less than 2. How can we say that? It is very simple. Observe the 2 rectangles. We have taken 2 rectangles. In the 2 rectangles, what we have done? I have colored 5 parts with yellow and 1 part with violet. So 5 by 3 is greater than 1 part, but 5 by 3 is less than 2 parts. As the denominator is 3, we have to make 3 equal parts between the numbers. Now consider the number line. I have drawn 4 vertical lines separated with the equal distance. Next to the left I have taken 0, next 1, next 2, next 3. Now I made 3 equal parts between 0 and 1, next 3 equal parts between 1 and 2, next 3 equal parts between 2 and 3. 0 can be taken as 0 by 3, and if I consider the first part which is out of 3, I have to take it as 1 by 3, next 2 by 3, next 3 by 3. 3 by 3 is also called 1, right. Next 4 by 3, next 5 by 3, next 6 by 3, next 7 by 3, next 8 by 3, next 9 by 3. Children, you can clearly understand here that 3 by 3 is equal to 1, 6 by 3 is equal to 2, and 9 by 3 is equal to 3. Now can you observe our required rational number 5 by 3 on the number line? Yes, here it is. Now let us represent a rational number which is negative. Which are negative numbers? Which are less than 0, right. Let us take the example minus 5 by 7. Here the denominator is 7, so you have to make 7 equal parts between the numbers, and negative numbers always lie to the left side of 0. So you have to remember these things. As the denominator is 7, we have to make 7 equal parts between the numbers, and one more thing, negative numbers always lie to the left side of 0. Children, observe the number line. Here I have drawn 3 vertical lines separated with the equal distance. Now I am making 7 equal parts between the numbers. Next, at the center I am taking 0, to the right 1, to the left minus 1. 0 can be taken as 0 by 7, and we are considering the first part out of 7. So what we have to do? We have to take 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 and 7 by 7, which is equal to 1. and to the left first part out of 7 if I consider, I have to take it as minus 1 by 7, next minus 2 by 7, next minus 3 by 7, next minus 4 by 7, next minus 5 by 7, next minus 6 by 7, next minus 7 by 7. So, on the screen you can observe that 0 by 7 is 0, 7 by 7 is 1 and minus 7 by 7 is minus 1. Now, can you observe our required rational number on the number line? Yes, here it is. Representation of a rational number which is an improper fraction. Let us take an example, 2 1 by 3. So, 2 1 by 3 will be more than 2, but less than 3, and it is not a improper fraction, it is a mixed fraction. So, what we have to do? We have to convert this mixed fraction into improper fraction. How to convert? Let us see. First I am writing 2 1 by 3. What is the denominator? 3. This should be multiplied with 2 and then 1 should be added. So, what I am doing here? 3 into 2 plus 1 by 3, which is equal to, what is 3 into 2? 6 plus 1 by 3. What is 6 plus 1? 7 by 3, right. So, 2 1 by 3 is a mixed fraction. After converting that into improper fraction, we are getting 7 by 3. Now, let us represent this 7 by 3 on the number line. Children, first draw a number line. Now, I have drawn 4 vertical lines separated with the equal distance. Next, to the left I have taken 0, next 1, next 2, next 3. Now, I am dividing 0 to 1 with 3 equal parts, next 1 to 2, 3 with 3 equal parts, next 2 to 3 with 3 equal parts. 0 by 3 can be taken as 0, and if I consider the first part to the right of 0, it is out of 3. So, what I have to take? You have to take it as 1 by 3. Next 2 out of 3, so 2 by 3. Next 3 out of 3 means 3 by 3. 3 by 3 is also known as 1, right. Next 4 by 3, next 5 by 3, next 6 by 3, next 7 by 3, next 8 by 3, next 9 by 3. Children, on the screen clearly you can understand that 3 by 3 is equal to 1, 6 by 3 is equal to 2 and 9 by 3 is equal to 3. Now, can you observe our required rational number on the screen? Yes, here it is. Now, let us identify rational numbers when number line is given. Let us consider an example. Children, observe the number line. Here there are some rational numbers between minus 1 and 1. So, we are trying to find the rational numbers which are in G, R, E, A, T places. Now, before going to this, let us consider the right side of 0. To the right side of 0, there is alphabet A, which is at which position? 1, 2, 3, third position. Out of how many parts? 7 parts. So, let us identify the place values of this. Out of 7, I am considering 3. So, I have to take A value as 3 by 7. Now, let us go for the alphabet T. 1, 2, 3, 4, 5. So, T is at 5th position out of 7. So, what should be the rational number representing T? It should be 5 by 7, right. Next, to the left, we are getting first alphabet as E. Let us find the value of E. As it is the first position to the left, we have to take it as minus 1 by 7. Total parts is 7. Next, letter is R. It is at which position? 1, 2, 3, 4. So, to the left it is 4. So, what we have to do? We have to take it as minus 4 by 7. Next, if I consider the last one, that is G, it is at 6th position to the left. So, what we have to do? You have to take it as minus 6 by 7, right. So, what are the place values of these rational numbers? For G it is minus 6 by 7, for R it is minus 4 by 7, for E it is minus 1 by 7, for A it is 3 by 7 and for T it is 5 by 7. Now, let us consider another number line to identify the rational numbers again which are less than 0. Children, now you observe the number line. On the number line, there are 4 parts between the numbers. So, the denominator will be 4, and here we have to identify the place values of S, U and N. Okay. Now, if I consider the S position, it is at third position to the left out of 4. So, what we have to take? Minus 3 by 4. Next, consider the U, it is at which position? Fifth position to the left. So, we have to take it as minus 5 by 4. Right. Next, consider the nth position, it is at which position? 1, 2, 3, 4, 5, 6, 7. At 7th position to the left. So, we have to take it as minus 7 by 4. Okay, children. Like this, you can identify any number of rational numbers when a number line is given if you know the denominator. Now, let us recall what we have learnt in this session. Smallest natural number is 1 and highest cannot be defined. Smallest whole number is 0 and highest cannot be defined. The collection of positive numbers 0 and negative numbers is called integers. Smallest and highest integers cannot be defined. Numbers which are in the form of p by q, where p and q are integers and q not equal to 0 are called rational numbers. 0 divided by 0 and any number divided by 0 cannot be defined. In decimal form of numbers, terminating decimals and non-terminating but recurring decimals are called rational numbers. Okay, children. Now, based on today's session, you try yourself to represent the following numbers on the number line. Represent 8 by 11 on the number line. Represent minus 6 by 5 on the number line. Represent 4 1 by 2 on the number line. For better understanding of the concepts, solve the worksheets. Please visit the official website of SIET for worksheets. Thank you.